to prove that cos x plus sin x divided by cos x minus sin x minus cos x minus sin x divided by cos x sin x here gives us 2 tan 2x there. Okay. So now here, what we're simply going to do here is we make what we have on the left hand side a single fraction here. So what we mean here is we're simply going to have the common denominator here is simply the product of the two denominators that we have here. So down here we're going to have cos x minus sin x, open brackets, cos x sin x like this here. So now if you divide cos x minus sin x into the denominator here, we simply remain with cos x plus sin x. If we multiply this and this here, we're simply going to have cos x plus sin x squared like this here, minus this side here. If we divide this here into what we have here, we're simply going to have cos x minus sin x squared here. So now, expanding the brackets there, we just simply have cos x plus sin x and also cos x plus sin x minus this side cos x minus sin x okay. So we have cos x minus sin x, also cos x here minus sin x here. Then we divide everything here by cos x minus sin x and also cos x plus sin x like this here. So now on top here we're going to have cos squared x plus cos x by sin x, we get cos sin x cos x, and these two here, so meaning that we're going to have 2 sin x here cos x here plus sin squared x like this here. Then minus this side here, we're going to have cos x squared x here minus 2 sin x cos x there plus sin squared x like this here. Then we divide everything by the product of what we have below here, which is simply going to be cos x by cos x. We get cos squared x minus sin x cos x like this. Then these two here are simply it's plus here, so then these two here we get minus sin x cos x here, then negative sin x by cos x here we get negative sin squared x like this. Now here you notice that here if you add okay, let me just write this step here. So cos squared x plus sin squared x plus 2 sin x cos x. Then this side here we have minus here cos squared x plus sin squared x minus 2 sin x cos x like this here. Then we divide everything by what we have below here. Let's also rearrange what we have below here. So we have cos squared x minus So that's supposed to be minus there, sorry. Okay, so cos squared dx minus sin squared dx here, then this here plus sin x cos x here minus sin x cos x like this here. Now, from the Pythagorean theorem, from the Pythagorean identity there, we know that cos squared x plus sin squared x gives us 1 here. Then we're simply going to have on top here. So where there's cos squared x plus sin squared x, we're going to put a 1. So what I mean here is, we know that sin squared x plus cos squared x simply gives us 1 like this here. Then the other identity that we're going to use here is, we know that sin 2x simply equals to 2 sin x cos x like this. Then we also know that the double identity for cosine function, cos 2x simply equal to cos squared x minus sin squared x like this. So we're going to use these identities later on. So now, here, cos squared x plus sin squared x, we're simply going to have a 1 there, plus 2. Here, we have sin x cos x like this, minus, inside the brackets here, cos squared x plus sin squared x, we have a 1 there, minus 2 sin x cos x like this, divided by, below here, this term and that term will cancel, because this is positive and that one is negative. So we are left with cos squared x minus sin squared x like this. So then, from the double angle identities here, we know that this here is simply equal to 2 sin x here. So 2 sin, or sin 2x rather. Let me just scroll down a bit. So here we have 1 plus sin 2x minus, here negative by 1, here we get negative 1, negative by this here, and we know that the identity for this is sin 2x here. So we're going to plus sin 2x here. So these two identities here are coming from what we have there. So now, we divide by, we check what we have below here. We have cos squared x minus sin squared x. So this is an identity for cos 2x like this here. So on top here, positive 1 minus 1, we get a 0 here. If we add sin 2x and sin 2x, we're simply going to get 2 sin 2x divided by cos 2x here. We know that if you divide the sine function with a cosine function, you get a tangent function. So meaning that you are going to have 2 tan 2x like this here, which is equal to the right hand side, which is required in the question.